Imagine a time when there was nothing, no space, no time, no light. Then about 13.8 billion years ago, a tiny point of energy exploded. This explosion, called the Big Bang, created everything in our universe. It was like a giant firecracker going off, flinging energy and matter in all directions. At first, the universe was incredibly hot and dense, but as it expanded, it began to cool down. Imagine a balloon being inflated. As it gets bigger, the surface cools down. The universe did the same thing. This cooling allowed tiny particles to combine and form the first atoms. These atoms, mostly hydrogen and helium, would become the building blocks of everything we see in the universe today, from the largest stars to the smallest grains of dust. The Big Bang wasn't just an explosion, it was the birth of our universe. After the Big Bang, the universe was filled with giant clouds of gas and dust. These clouds, called nebulae, drifted through space, their particles bumping into each other. Gravity, the force that makes things fall down on Earth, started to pull these particles together. Over millions of years, the clouds got denser and hotter. Think about squeezing a sponge. It becomes smaller and more compact. That's what gravity did to the gas clouds. Eventually, the pressure and heat at the center of these clouds became so intense that nuclear fusion began. This is when atoms fused together, releasing an incredible amount of energy. This energy burst outwards, pushing against the crushing force of gravity. And with that, a star was born. Stars are giant balls of hot gas that produce their own light and heat. They are the cosmic furnaces that create the elements necessary for life, like carbon, oxygen, and iron. Without stars, there would be no planets and no us. When a star is born, it doesn't use up all the gas and dust from its parent nebula. This leftover material, like crumbs around a freshly baked cake, continues to orbit the young star in a swirling disk. Within this disk, gravity again plays a crucial role. Dust grains, pulled together by static electricity, begin to clump together, forming larger and larger objects. These clumps attract more particles, growing over time. Imagine rolling a snowball. As it rolls, it picks up more snow, getting bigger and bigger. That's similar to how planets form. These growing objects, called planetesimals, collide with each other, some sticking together, others shattering apart. Over millions of years, this chaotic dance results in the formation of planets. Some planets, like Earth, form closer to the star and are made of rock and metal. Others, like Jupiter, form farther out, where it's cold enough for gases to freeze, becoming gas giants. Our solar system is a family of 8 planets orbiting the Sun. We have rocky planets like Mercury, Venus, Earth, and Mars. Then there are the gas giants, Jupiter, Saturn, Uranus, and Neptune. Each planet is unique, with its own story to tell. For example, Jupiter is so large that it could fit all the other planets inside it with room to spare. Saturn has stunning rings made of ice and rock. And Mars, our red neighbor, might have once had flowing water on its surface. But among all these celestial wonders, Earth stands out as truly special. It is the only planet we know of that harbors life. Our planet has the perfect ingredients for life as we know it: liquid water, a breathable atmosphere, and a stable climate. Earth's distance from the Sun, its tilt, and its protective magnetic field all contribute to its habitability. It's a delicate balance, a cosmic coincidence that makes our planet a rare and precious oasis in the vastness of space. We are fortunate to call Earth home, and it's our duty to protect and cherish this pale blue dot.